We are now ready for stage 2 of the functionality for our TP camera system. Primary functionality, that is. And really, this is all about a single method, that being, which method?
Handle player input.
Handle player input. Now, what is handle player input going to do? My goal here is I'm going to start off by giving a very high-level overview and try to break down all of the data that we're going to be taking in, make all that make sense, and then we'll just go from there. So, for starters, it's really all about mouse input. So, I'm going to try to draw a mouse. We'll see how well this goes. And our mouse is going to have a scroll wheel, and it'll have a right mouse button, which is really, that's all that's important. It'll have a left mouse button too, but that's significantly less important for our purposes. And we'll say this is a wireless mouse, but we will label it. Alright, so your mouse moves in 2 axes. These being X for horizontal and Y for vertical. Now, we're going to be actually taking in that motion and using that later on to translate our camera. There's a couple of factors for this that are going to be important for you. We're only going to be calculating this in terms of camera motion if right mouse is being pressed. So that'll be one thing that we're looking for later on. But I just want to make sure we get that out of the way now. So the actual job that the mouse is doing is dependent on whether or not right mouse is down. If it's not down, we're not going to be doing any of the things that we'll be discussing here in this video. Alright, now here's how this is going to work. Mouse X is going to control what exactly?
Well, mouse X is going to control our rotation about our look at target horizontally.
Gotcha. Now at this point, are we doing that or are we just storing the information?
We're just getting the information from the mouse. Nothing's going to be applied until we do the calculate and update position. We are just getting that information and conditioning it, getting it ready to be used.
Okay. Now, these are not the only 2 axes we're going to be reading from. There's a separate one here in our mouse wheel. Now, I'm going to break this out into kind of like a picture-in-picture view. So this is a little side view of our mouse wheel. And your mouse wheel can, of course, spin in 2 directions, being forward and back. And we're going to be taking that in too because this is going to eventually wind up controlling our camera distance. So while X and Y will end up being used to calculate the rotation of the camera, we'll be using the mouse wheel to control our distance. Now, mouse wheel will not be dependent on holding down the right mouse button.
Right.
So for now, let's just talk about how we're going to be getting this data. So the very first thing we're going to do is check and see, and forgive me, this is just old Maya habits. Right mouse button is RMB. So we're going to check and see if right mouse button is down, more or less, if that's being pressed.
Right.
And if that's being pressed, then we have some jobs to do. So let's talk about those. First off, we need the axial inputs from our mouse. But we're not just going to take them directly. Just like with many other PC games, we're going to be exposing access to mouse sensitivity. So axial motion, and that's in both X and Y in this case, will get sensitivity applied. And that's really easy. That's just a multiply value. So if we move over, I mean, just 3 arbitrary mouse units, we're going to multiply that by a sensitivity which could be 5, resulting in 15. I mean, that's the basis of the math behind it. Now, that's not all, however, because our 2 axes are not treated in the same fashion. There are some special rules. X can go as far as it wants to. X is an unlimited value in this case.
Right. You can go as far as you want to the left, as far as you want to the right. Once it hits 360, it wraps around and starts all over again.
All right. So you're never going to feel a limit while you're using that. I mean, the numbers themselves may cap between 0 and 360, but that's all under the hood. The player's never going to feel any blockage there. Y, however, is going to have a limit. I don't want to use an equal sign. Let's use an arrow. And that is so that when we have our little character here, our camera can have a limit for how far up and down it can arc. So we don't end up going up underneath the character and flipping upside down, or over the top of the character and flipping upside down. Now, here's where things get a little bit special. I'm going to put that in a box, and I'm going to put stars at the corners. I don't know why stars, but because this guy, I just want to make sure that you understand that applying these limits is going to be a special thing, and I'll talk about why it's special here in just a moment. We'll get to that. All right, next, we need to get our mouse wheel input and check to make sure that our distances aren't exceeded. We've got to basically clamp the inputs from our mouse wheel. So get, you mind if I abbreviate mouse wheel to MW?
I'll go for it.
Inputs. And we're going to clamp these between distance min. Is it distance min or is it min distance?
Distance min.
Thanks.
Mm-hmm.
Distance min and distance max.
And of course, if you reverse them, I just write them in.
Yeah, exactly.
Play it off like that's what we meant to do.
Exactly. So we've got to make sure that those end up being clamped, because we can't allow that input to. Well, in the end, that's really just going to be setting a desired distance anyway.
Right. And then it also gets its own sensitivity.
Right. Now, that's true. So even before we get that, the mouse wheel inputs, I'm not even going to worry about the clamp right now. Let's actually back up just a little bit. The mouse wheel is going to end up with its own sensitivity applied. Which is very useful if you need to fine-tune it. You know, if you just don't like how slowly you roll, if you really feel yourself having to really spin the mouse like crazy to get towards or away, we're going to expose the sensitivity value so you can speed that up or slow it down. And there's a lot of games where I wish I could do that on. As a matter of fact, I eventually got to the point where I picked up a Logitech MX 518, I think, the 518, and that had variable mouse wheel speed right on the mouse. So you could speed it up, because that's such a nice feature to be able to change that. And then in the end, this information will end up being clamped. So that's a quick look at all of the things we need to manage. We've got to take a look at our x-axis. We've got to take a look at our y-axis. We've got to take a look at our mouse wheel input. We've got to make sure we know if the right mouse button is down, because if it's not, we don't need to worry about whether the mouse is moved left, right, up, or down. Now, in handling all of this input, and I'm going to go ahead and get myself a new sheet of paper here. We need some things. So first off, we're going to need some fields, yeah?
Right. The ones that we're mentioning, we're going to expose our sensitivity.
Okay.
So we need 3 public fields that are going to hold floats, and they're going to be X mouse sensitivity, Y mouse sensitivity, and mouse wheel sensitivity.
Now, are you putting underscores in there?
Yes, I am.
Okay, that's what I thought.
And that's just to make it a little bit easier to read in the Unity inspector.
Sure. And then Y mouse sensitivity. And this is mouse wheel.
Mm-hmm. Mouse wheel sensitivity.
And those will hold values that will become multipliers, to which, and we'll apply that multiplier to whatever our incoming input happens to be.
Right. Now we have 2 additional public fields that we need to set.
And let me just, we'll put kind of a generic definition down. Sensitivity values to be multiplied by inputs. And that's for all 3 of these axes.
Right.
All right, next.
We've got to have fields to hold our limits for the y-axis of the camera.
Okay. Now, are these still going to be public?
Yes, they are.
Okay.
Again,
Now,
they're still floats, so they're going to be y min limit and y max limit with an underscore.
Okay, so it's y underscore min limit?
Yep.
Okay. Make sure I understand. Because I'll write it wrong and somebody will send me an email. Y limit, also x limit? No.
No, y max.
Y min, y max. Thank you. I knew that. My brain just switched to another mode for a minute.
Kind of a sidebar is if you did want to limit your x you could take and set your own X min and max limits and clamp that as well.
But then you really should have some way to rotate the character around that isn't like this.
Right. But this is just a basic to get them started. I'm just saying if they wanted to do it.
Your character controller could be way different than ours. So yeah, there's no reason why you couldn't limit. We're just not in our example. So we had Y min limit, Y max limit. What else was there?
Well, as far as public fields, this is it.
Okay, well let me go ahead and put a definition for these, because these define the limits of our Y rotation. And I just want to make sure everybody's clear as to what that means. So if we have our character still sitting here doing his thing, our camera, when looking at the back of his head, or really looking at any part of him based on that look at target, can rotate up and it can rotate down. And these numbers will literally define rotational limits that we're going to stop at. All right, so now what?
Well, we can start going over what we actually do inside the method itself.
So we're ready for the actual method process. So what are we going to do first?
Well, first we're going to create a var, call it dead zone. Because the mouse wheel is a sensitive control, it could possibly have some drift associated with it.
Okay.
So we want to have a dead zone for it. So if you bump it, it just doesn't start moving your camera.
It's like if you have one of those, I'm not going to say that they're annoying, I'm just not a big fan, those mouse wheels that have no click zones. I love the click zone. It's like, it's so reassuring to roll the mouse wheel and feel that little bit of a click. And then there's the hardcore gaming mice where I've used them and I'm okay with them and I understand the level of precision. I just always feel like something's missing. It's like, where's the click? I can't feel the click. So, all right. So we're going to establish a dead zone variable. And what that's going to do, if I was to draw it, let me just pick on a little corner over here. So here's our mouse wheel. And we know that it can roll positively and we know it can roll negatively. And all we're doing is we're just establishing a little zone of change, a little zone of delta, where if we don't break out of that dead zone, we're not even going to detect that a motion has taken place. Okay. So once we've created that dead zone var, now what?
Well, we need to check to see if our right mouse button is down.
Okay. Check for, and forgive me again for my old Maya habits, but we're going to say check for RMB for right mouse button.
Right. So if our right mouse button is down, we're actually going to look at the inputs coming in from the mouse's x-axis and y-axis. If it's not, we're going to completely ignore that part.
Actually, the way I'm going to do this is if not down, do nothing.
Well, it will do something.
It will do something. Okay.
Yeah, it does do some processing.
But it's not going to move the camera.
It's not going to move, well, it's not going to orbit the camera.
Okay.
But we can still move the mouse wheel.
Okay, if not down, don't move, don't orbit camera.
Right, don't orbit the camera. So we're not going to be looking at any input on the X and Y of the mouse.
But if it is down?
But if it is down, we need to get the X-axis input from the mouse, multiply it by our sensitivity, and we need to increment our mouse X by that amount. Okay.
So let's get the X-axis input data. Not DAX, but data. We're going to multiply that by our sensitivity.
Yep, our X mouse sensitivity.
I'm going to abbreviate a few things here because I've got so little space. So multiply that by our X sensitivity,
right,
and then increment that?
We're going to add that to whatever our last X mouse was.
Okay. So it would be like plus equals our current X input?
Yes.
Okay. Plus equals the X input. And that's not really the name of a variable, it's just that's that actual factor.
Right.
So we're taking wherever the mouse happens to be and we're incrementing it.
Right. So we look at the mouse rotation, and then if we move our mouse left or right, we're going to take that amount, multiply it by a sensitivity that increases that amount, and then we either increase our last rotation around X,
right,
or subtract from it depending on the direction that our mouse was moving.
Right, and just as a reminder, when I write notes like this, these have nothing to do with programming syntax.
Right.
This is just shorthand for me getting an idea of what we're going to be doing.
Now, after we do this, the next thing we do is do the exact same thing again for the y-axis.
Yeah.
but we invert the y-axis.
So we'll do the same thing. We'll get our y-axis input data. We will multiply this time by y sensitivity. But we're going to subtract from our existing y mouse input values. And the reason we do that is really, again, just so that we can invert the mouse value. So as we pull down, the camera rotates down underneath the character. As we push the mouse forward, the camera rotates up above the character.
Right.
Now, there's no reason why on your end you could put a Boolean value that was exposed to the user inside of Unity. So you could say invert mouse look, and there's so many games that do that. But because of the nature of our third-person controller, after playing it a lot, it felt really natural for us to do it in this way. So that's just how we're going to do it.
Right. Now we get to have some fun.
All right.
Because I think that little star box of yours comes into play now.
Yeah, and it's probably time for me to get a new piece of paper out anyhow. So, earlier on, I mentioned that we were going to be clamping, wasn't it the Y input?
Yes. So we're going to be looking at mouse Y.
That had special stars in the corners of the box.
Yep.
And now we get to finally kind of discuss why that was so special. Because the clamping action, the clamping activity, is actually going to be done in a separate class.
We're going to finally get around to coding out our helper class that we had mentioned several videos back. And this is going to be the first of two methods that this class is going to hold.
So, can I call him helper.cs?
Sure.
Sure. So that'll be our helper class. Now, in this case, all he's really going to be doing is clamping this angle, yeah? All right. And I'm not going to go too far into the actual syntax here. We'll kind of code him as we go. But the idea is that for the time being, his only job is going to be to have one method that we're going to call clamp angle. Now, clamp angle is going to take in some values, yeah?
Right. We're going to pass in the angle.
Okay, go ahead.
I was going to say, and after we
and then
pass
our limits.
Yep, we're going to pass in our min limit followed by our maximum limit.
I'm going to try to squeeze this in, so we'll just say min and max. So, I mean, it makes sense because it's a clamp. It's, here's the number we're going to be clamping. Here's our minimum value. Here's our maximum value. And then he's just going to return the result, yeah?
Well, he'll do some formatting too, and when we get to coding, we'll explain what's going on. But he's going to clamp our limit, but he's also going to ensure that whatever angle that we send in is always going to return in a value between negative 360 and a positive 360.
So he's going to check that on the value that comes in?
Well, what he's going to do is, let's say, for instance, you sent in an angle of 900. It's going to convert that down to what that angle would be
offset
between
from 0 to 360.
Exactly.
Right, which would be 180.
Yes, I believe so.
Yeah. So because 720, 180, 900, yeah.
Yep.
So if you did send it 900, he'd fire back 180. Okay.
Which is the same angle.
Or wait a minute, he'd fire back 180, or he would use 180 in his clamp calculation.
He would use 180 as long as 180 was within your min and max. He would fire it back. But if it was outside of your min and max, he would clamp it and send that back.
Okay. So in a way, it's like I don't want to use the term normalize to 360.
No,
it's just not really accurate.
Right.
He's going to convert whatever rotation you send it to a 0 to 360 value.
Either in positive or negative.
Okay.
So he can return a negative 360, or he could return up to a positive 360.
Gotcha. And again, yeah, he's gonna get rid of any rotations beyond 360 degrees and give you the remainder.
Exactly.
All right. And then he'll make sure that gets clamped.
Yep. And then he returns that to you.
So, all right, either convert rotation to 0 to 360 value, either positive or negative, then clamp, then return. And right now, that's his whole job. So that's what we're going to be doing here. We're going to, inside of TP camera, we're going to utilize this function inside of helper. we're literally going to say something like, and if my syntax is off by a little, that's okay. Again, I'm not trying to code with my pen. But we're going to say something like helper dot clamp angle. We're going to feed it our mouse Y value, and then we're going to feed it our Y min limit that we established earlier because we talked about needing that field, and then our Y max limit. Semicolon. So that probably is really close to what we're going to do. It's just we're not actually going to do the math in this class. The helper class is going to do it.
Right.
Now, before you start going, well, why would you do that? I mean, if this is the only class that needs to know that information, why don't you just do the math right here in this class?
Right. But we do it this way in case any other class I ever use needs to use this.
Not to mention, as we get into more complex derivations of this system, we're going to be expanding on the helper class and giving it other tasks to do as well. So this is kind of looking ahead in the future. And you can do this in your code. There's nothing wrong with having a helper class that just deals with odd little tasks that multiple classes may need to do. That way you don't have to perform these specific kinds of operations individually in each class. You can just call it and say, oh, hey, helper dude. It's kind of like you calling up the machine shop and saying, hey, I need this particular part fabricated. Can you make one and send it to me? And they're like, yeah, sure, here you go. So we've got that. That's going to deal with our clamp for us. And then finally, we need to deal with our mouse wheel.
So with our mouse wheel, what we're going to do is we're going to do a check to make sure that we're outside of our dead zone.
I'm going to kind of draw a thing here. And let's just, this will be our mouse wheel area. So we're going to check to make sure we're outside of dead zone. Okay.
And if we're outside of that dead zone, we're going to apply our. We're going to take that value. We're going to apply our mouse wheel sensitivity to it. We're going to basically multiply it by mouse wheel sensitivity.
All right. We'll say apply mouse wheel sensitivity. Okay.
And we're going to subtract that value from our current distance. Now we're subtracting it because that's going to reverse the mouse wheel input, which will give us the action of moving the mouse wheel away from you. We'll zoom the camera in, pulling the mouse wheel back to you will pull the camera out.
So we need to flip that.
And then we're going to take that whole thing, and then we're going to clamp it to our minimum, or distance minimum and distance maximum.
Now, is this actually going to control the distance directly?
This is actually going to be set and stored in our desired distance.
That's what I thought. I thought at this point we'd still be handling one of our desired values so that we could apply some smoothing to it later.
Right.
So all of this is going to be clamped. So I've got to... You make the most of my tiny little screen space. Clamp between our distance min max.
Yep. And then we store it in desired distance, because we still have more processing that we have to do with this. But we won't do it in this method. We do it in our calculate desired position method.
Okay, so but that's the important thing here, is that the result of this is going into our desired distance, not our actual distance. This is just going to be used to designate a target that we would like to move to. So, I mean, if we were looking at this along the line of the distance to the character, and I'll just draw the character as a simple oval in this case, and then we have our clamp limits to control how far the camera can get away. And if we said, all right, well, here's our camera, by rolling the mouse wheel, first, we've got to apply our mouse wheel sensitivity to control how far we would move. So if we started off just assuming we were right here, and we roll the mouse backwards, that's going to move this point by a value coinciding with our mouse sensitivity. So we'd multiply it by mouse sensitivity to make sure we knew how far we were going to go. We clamp that to make sure that we don't accidentally go beyond our distances. And then that just gets applied to our desired distance, so that later on a smoothing factor, which we're not going to talk about just yet, that'll come up later, is going to physically take the camera and smoothly transition it to this point.
Mm-hmm.
All right. I think that covers everything.
I believe so.
Yeah.
It's time to code it.
Yeah, so let's, I think that'll wrap things up for this video. Let's jump over into Visual Studio, and we can code out our, what is this? What's the name of it? I forgot the name of this method again.
Oh, this is handle.
Handle. I knew it started with an H, but I kept thinking helper class because now I've been all thrown off. So I just want to mention real quick. So yeah, we know what we're doing. One more time. So we've got our mouse sensitivity, our mouse wheel sensitivity. We've got our min and max limits and rotation that we're going to be working in between. We're going to set up a dead zone variable for the mouse wheel. We're going to check for our right mouse button down. If our right mouse button is not down, we are not going to move the camera, at least not in its orbital directions. We can still roll it in and out. That's going to be just fine. But if we are holding down the right mouse button, we're going to get our x-axis data, multiply it by sensitivity, and then increment our x input value. We're going to take our y-axis input data, multiply by y sensitivity, and then decrement our y input value, and that's how we invert the axes of the mouse, so that as we rotate the mouse up, so we push the mouse forward, we are rotating the camera up into the air. All right, and then finally, this gets us to our quick helper class, which is just going to be here to help us handle the clamping process. If we were to feed this a rotation beyond 360, it is going to remove out any rotations beyond 360 and just give us the remainder. So like a value of 700 or 720 would end up just being 2 360, so you'd end up with 0. So then that's all that's doing. Now mouse okay, hang on. Once it does that, it's going to clamp it and then return that value. That's how we are going to be handling the clamps on either end of our Y rotation.
Right.
Then we've got our mouse wheel. We're going to make sure that we move outside of that specified dead zone. We're going to apply our mouse wheel sensitivity to control how far we move, but we're not actually moving the camera. We're just moving that desired position, which is just going to be a target, and we're going to smoothly transition to that target using another class that we're going to be coding later.
Well, another method.
Another method. Thank you. Another method. Excuse me. I meant method. All right. I think that's everything, and I think I've beat the horse into the ground. So now let's jump over and start actually programming this. That's going to wrap things up for this video. Thanks a lot.